Good afternoon and welcome. Today's topic will be Microsoft Azure Search. RDA's Tech Talk series is designed to be a 30-minute technical presentation around a current technical topic, and for today's talk we will have some presentation and some demo. And now I would like to introduce you to our speaker for today, Jamie Rance. As a principal architect with RDA, Jamie has been working with .NET Framework and other Microsoft technologies for over 14 years and has extensive experience in architecting and developing custom solutions for a variety of clients in multiple industries. Jamie specializes in ASP.NET, SharePoint, software architecture, and cloud computing initiatives. Jamie holds a MCSD certifications for enterprise application development and for SharePoint administration and development. So thanks, Jamie, for joining us today, and I will turn the presentation over to you.
Okay, thank you, Patty. And thanks for joining today's Tech Talk. My name is Jamie Rance. As Patty said, I'm a principal architect with RDA Corporation. And this presentation is going to be an introduction to a brand new Search as a Service offering from Microsoft called Azure Search. So let's have a quick look at the agenda. So my goal in this presentation is to spend as little time in the slides as possible and spend most of the time in an actual real-life demo. That being said, we will quickly introduce Azure Search. I'll discuss some of the high-level points about Azure Search, at a high level how it works, and then we'll jump into 3 different demos. First demo will be showing you how to provision a search service within the Azure portal, and I will use the Azure portal to then go ahead and create some indexes for that search service. And then Microsoft has released a comprehensive REST interface for Azure Search, so I will demonstrate how to use that, how to work with that to create search documents and search on those documents. And then finally, if time permits, I'm going to jump into a Visual Studio demo that's been put out there by Microsoft that showcases some of the more advanced functionality of Azure Search. Once that's done, we'll jump back into the slides, and I will close it off with some references and some tips and see if anybody has any questions. So with that, thank you, and let's get started. So the first question is, what is Azure Search? In a nutshell, Azure Search is a search-as-a-service solution that's offered by Microsoft. It is built on top of Elasticsearch, which in turn is built on top of Lucene. It is now a first-class citizen within Azure, so that means it has all the benefits of being a first-class citizen in Azure. It's easy to find, it's easy to provision, and it has elastic capabilities there. It allows you to quickly and easily create very deep and comprehensive search experiences. As from a developer standpoint, it's extremely easy to set up, extremely easy to develop for, and to consume the search capabilities. That makes it great for regular websites, for online retail sites, e-commerce sites, social sites, wikis, blogs, and things like that. So tons of uses for this. And as you'd expect from a modern search engine, we have a lot of the advanced search functionality there. We have the capability of facets, we have the capability of suggestions or autocompletes, word stemmings, the ability to correct spelling mistakes, synonyms, and things like that. And as I mentioned, this is a first-class citizen in the cloud, so as you would expect with all cloud services, it does support this elastic scaling where as demand increases, you can add more resources. As demand decreases, you can take away those resources. So basically paying for what you use. Okay, so the next is how is everything put together within Azure Search. So we have Azure, and within Azure we would create a search service, and I'll actually show this in the demo. Within the search service itself, we have indexes, and indexes is where all of our data is stored for the search service. The indexes have a rigid schema. Think of them as kind of like a database table that have predefined fields with the various types. You have the support for strings, collections of strings, booleans, integers, date-time offsets, geographical points, things like that. And you define this rigid schema. Each index has its own schema, and then you add documents to the search index. Now, the documents themselves, when I use the term documents, I don't mean PDF and Word documents. In the world of NoSQL, Elasticsearch, and Lucene, the term document is used to represent kind of an object. In this case, for Azure Search, we're talking about a JSON object. So we are essentially creating JSON objects and storing it in the search index. When we place it in the search index, Microsoft then takes those JSON objects and provides indexing on those, faceting, stemming on the data within those indexes, and exposes a very rich REST API for us as developers to be able to call into and perform some advanced queries against the items within those indexes. So that's Azure Search at a very high level. Let's go ahead and jump into some demos of that. So let me jump into the Azure portal. If you're not aware of this, this is the brand new Azure portal. It's currently in a preview state right now. All of the new all the new services that are being released by Microsoft, such as DocDB, Azure Search, things like that, those are only available in the brand new portal. So it takes a bit of getting used to, but once you do, it's actually a very effective user interface. So to create a new Azure Search service, I'm going to click on the new button at the bottom here. And if I scroll down, I'm going to click on this Search as a Service offering that Microsoft has. And I'm going to call this RDA. And it gives us the option to select from 2 different pricing tiers. So every Azure subscription gets a free tier right here, and that allows you to create up to 3 indexes, to index up to 10,000 documents, have up to 50 megabytes of storage. It is using shared resources, so shared machines, and there are no scaling capabilities there. That being said, I've used the free version, and it is still extremely fast, extremely powerful, and if you don't have really a need to go beyond this, this might be enough for what your needs are. If you need something a little bit more, though, we have the standard tier here. That allows you to index up to 15 million documents per unit and up to 50 indexes per unit. And it allows you to scale out up to 36 units. So as you can imagine, that really is a massive amount of data that you're storing and indexing on. Has up to 300 gigabytes per unit, and you are getting dedicated resources here. That means that when you actually create this, Microsoft is provisioning virtual machines behind the scenes with Elasticsearch on it, and provisioning all the services ready for you to be able to consume that. So you are getting dedicated virtual machines there. So I'm going to go ahead and select that, and then within the resource groups, I'm going to select my demo resource group. And then Azure Search is currently available in 6 different data centers around the world. So for this, I'm going to select the Eastern US data center. And I'm going to go ahead and click the Create button. If I scroll over to the right here, you can see that it's actually provisioning the search application for me. Now, as I mentioned, this is actually provisioning virtual machines behind the scenes, so this does take a while. It can take up to about 10 minutes. So I have pre-created one here called RDA Demo, so let me jump into that and show you what happens after the search service gets created. So here's your little dashboard for the search service. We have on the left-hand side here keys. And if I click on keys, you can see that I'm given 2 admin keys. And the admin key is used every time you make a call to the REST service, the REST search service, you have to pass a key. And if you're doing any kind of updates, listing of indexes, any administrative type functions, you have to pass in the admin key to do that. You also have the ability to pass in a query key. So if all you're doing is searching against an index, you can pass in the query key, and that'll give you the same results there. And the idea there is that Microsoft wants you to be able to pass this key down to the client in perhaps JavaScript, maybe on a mobile device, and then call directly into the search service as opposed to having to route it through your middle tier as somewhat of a proxy into the end service. So that's a nice way to give out the key without giving away the secret. Also here we have the properties, and this is where we find the REST endpoint. So here you see our search service is called RDA demo. All search services end in .search.windows.net, and this is the actual REST endpoint for us to call into. And then brand new to the portal, this is recently added in the last few days, is the ability to actually create indexes within the portal. So if I click on this plus button here, I can go ahead and create a brand new index. I'm going to call this one blogs. And that appears down here. So I have one index in my search service. And then as I mentioned before, each index has a defined schema, a rigid schema. So we can come in here and add fields to that schema. So the first thing I'm going to add here is a title field, and I can make it retrievable, which means it'll be returned in the JSON results. I can make it searchable, which means it's included in the search. If I search for a term, this field will be searched. I can make it filterable, which allows me to do some more advanced filtering on the field. I can make it sortable. I can make it facetable, and that allows me to create a facet type interface, and I'll show that off in the AdventureWorks demo. It also allows me to make it available for suggestions, which is where you would use autocomplete. And again, I'll show that in the AdventureWorks demo. I come in here and create another field called description. Go ahead and click Save here. Scroll back over to the left, and you can see here I now have my index. I have three fields, an ID field, which is going to be my key. Think of this as the primary key field within a database table. I have my title and my description. So very easy within the Azure interface. I've gone ahead and provisioned a new search service. I provisioned an index within that search service, and I've defined the schema for that index. So let's go ahead and figure out how to add documents to indexes within search. So for that, I'm going to use a tool called Postman. This is a fiddler-like tool that allows me to issue REST requests against the REST API. On the left-hand side here, I have a list indexes query. And this is passed to me unauthorized, so hang on a second, Every query that you make to the search service requires an API version. So as you can see here, we have an API version. So what this is doing right here is it's making a request to my REST endpoint, RDA demo.search.windows.net, and it's asking me to list all the indexes that are available in that search service. And again, I pass in this API version, so it knows which version to use against. And I'm issuing a GET request here. So if I click Send, it's pulling back that blogs index that I just created. It has the fields. It has the ID key field, the title field, and description, along with all the various properties of those fields. So that's how you list the indexes. Now let's go ahead and create a brand new index. So for this, I'm going to create an index called Tech Talks. And this index is going to have a number of fields. It's going to have an ID field, which is going to be my key. It's going to have a title field, which is going to be the title of the Tech Talk, and I'm going to have suggestions equal to true. It's going to have a description field, a speaker field, a date field, a rating field, and a tags field. And the tags field is going to be a collection of strings. So this is tags for the Tech Talk. I'm going to issue this as a put request, and the actual URL is going to be /indexes/Tech Talk. So if I click Send here, it'll go off and it'll create that index for me. And as you see here, I have a status of 201 created. And it has the various fields that I just created there, my ID, my title, description, and so on. So now that I have this data there.
Hey, Jamie, I'm not
Did we
sure.
just lose audio connection?
Yeah, I'm not sure if what happened, but for once you went to this particular page, I couldn't hear what you were saying, so you might need to just repeat that part.
Okay, this last page here?
Yes.
Okay. So now now that I've created the index, I'm going to issue a GET request against that index. So to do that, I just use the REST URL /indexes/tech talk. And then if I issue that and click the send button, it'll go ahead and send that request off to the search service and return the results to me, as you see here. So now that we've gone through and created our search service, we've created 2 indexes, blogs and tech talks. Now let's add some documents to those indexes. To do that, I have this simple post request here. And if I expand this down, I can see that I have a JSON object that I'm sending up to the server. And this is the way that Azure Search expects you to pass off the documents. As I mentioned before, documents in Azure Search is just really a JSON object. So the action that we're going to be doing is a upload action. I'm going to pass through the ID. I'm going to give it a title. For this, I'm going to use Microsoft Azure Search. That's the title of this Tech Talk. Here's the description of the Tech Talk. Speaker, it's myself. We have the date of 11/5 today. We have a rating. I'm going to give myself a 5 on this. And then we have tags, and for the tags, I've got a collection of tags. One is Azure, and the other one is Search. And then on the second object that I'm sending, this is another Tech Talk that's going to be done by Shruti in a couple of weeks. And the title of this is Enterprise Data Warehouse Architectures in Azure. Highly recommend you checking that out. We have a description here for that Tech Talk. We have the speaker information. We have the date, another rating of 5. And then for the tags here, we have Azure, Data, and Warehouse. So now if I issue this post request, the response back from Azure Search is a 200. That means it was okay, everything went correct. And it'll actually give me back my data here, say that key 1 had a status of true, meaning it was successful, and it did not have any error message. So Azure is smart enough to, if you pass through 1,000 documents, which is the maximum amount of documents you can send through in a batch, you pass through 1,000, it'll try and commit all of those to the index. If it fails on a couple, it's still going to succeed on the other. And what it'll do is it'll return a 207 status to you, which will be an indication that you need to iterate through the result set to figure out what failed. And any failure will be here with the status of false, and it'll include an error message in there. So now that we have documents in our search index, let's go ahead and search against that. So to do that, I have a very simple REST call here. Here's my endpoint, and then from here I'm calling into the indexes. I'm going to call into the Tech Talks index, and I'm specifically querying against docs. And my search term is going to be data. So search equals data, and then again I have this, move that back, I have this API key right here, which is required on all calls to the service. So all I'm doing here is searching for any documents that have the word data in it. If I click send here, you can see that I have enterprise data warehouse architectures in Azure. This is Shruti's Tech Talk, and it's the only one that was returned. If I change this to be Azure, both results are returned, the Microsoft Azure Search and Shruti's presentation as well. So extremely fast. The speed is extremely impressive, whether we're dealing with 2 documents as we are here, or whether we're dealing with 2 million documents. The performance is very good, what Microsoft has given us. We can take this a little bit further. So we have a search here for Azure. This time we're going to filter it where the ratings is greater than 4. So as you can see here, we have just an OData query that we are sending through, and we're going to say, pull me back all search results, all documents that have a rating greater than 4. I click send here. You can see both of them are returned, and if I change this to be less than 4 and click send again, there are no results returned. And the capabilities go far beyond this. So this is using a filter. We can also include paging, where we bring the top 10 items back and we want to skip the first 10 items. So you can implement paging very easily doing that. You can also include facets, which I'm going to show in the AdventureWorks demo, and many more capabilities in there. I'm just kind of scratching the surface here. So with that said, let's jump into the Microsoft AdventureWorks demo application. This is available on CodePlex, so you can grab it and have a look at the code that's there. We have 2 projects. One is a catalog indexer, and what this does is it takes an AdventureWorks catalog database, and it's essentially just pushing the data from this into an index that's lived within Azure Search. So let me show you what that looks like in the portal. I have this search service here called AdventureWorks 1. If I click on that, scroll over to the left, here is my index. It's an index called Catalog. It has 294 documents in it. And you can see here I've got the various fields. I have name, product number, color. Color is going to be facetable. Price is going to be facetable. Category is going to be facetable. So these are all the various fields that we're going to be using as part of our catalog index. So if I go back into Visual Studio, I'm going to go ahead and run this MVC application. And you can tell this was written by a developer because the user interface is not the prettiest thing in the world. So if we actually start typing, if we start typing for bike, bug there. Let's start typing bike. It's making calls to the Azure Search service and asking it to pull back suggestions. So the suggestions for this is bike racks, bike wash, bike stands. So I'm going to go ahead and click bike racks here. Click search. And again, the user interface isn't the prettiest thing in the world, but it shows off the powerful capabilities with only a few lines of code and really one REST query that I've made to the search service. I pulled back search results, top 10 search results. I've included some pricing information, color information, the weight of the bike, and the size. And I have, on the left-hand side here, facets. And this is something that we're very used to with interfaces like we have on Amazon, where we can filter into various items. We can filter into various items. So we have here, we can pull up all black bikes, we can pull up all mountain bikes, and we can pull up ones that are between 1,000 and 2,500. So extremely easy, extremely powerful. The code to do this is pretty straightforward. I don't have time to go through this, but I highly encourage you, if you're interested in creating a search UI like this, the code is extremely easy to go through, and you can find out very easily how to create these kind of search pages. Okay, so let me go ahead and jump back into the slides, wrap it up with a summary just to kind of detail what I've shown here. So within a few minutes, I've created a search service, a couple of indexes, and queried against those indexes. And really, that's all there is to it, to create a search index and be able to search against that. It is a very compelling search as a service offering on Azure. Very easy to set up, very easy to begin development against. It does support elastic scaling, so that's critical when you're talking about things in the cloud. Up to 50 million documents per unit and 50 indexes per unit. One thing to note is that I was pushing data into the index there. You saw me adding documents to the indexes. That is currently the only way to get data into the indexes. From an architecture standpoint, I actually like that. It means that if I have business logic where I'm adding data to a database, at the same time I can kick off a process or a job to add that item to the search index, and then it's immediately searchable as opposed to having to wait for some crawler to go through. That being said, crawlers are in the works. Microsoft will be releasing some crawlers for this, so at some point in time we will be able to say, tell Azure Search to go to some blob storage and index the data in there for us. Or we will be able to tell it to go ahead and index some SQL database for us. I only touched on really the very basics of this right here. There is some additional things that I think are pretty critical to take away from this, and that's the performance tuning, the scoring profiles. If I have an online retail site and I want to promote certain products because perhaps I have more inventory in it or better margins on the product, I can change the weighting of the search results. Similarly with Tech Talks, if we wanted to put a higher rate on things that were rated 4 or 5 stars, we could do that very easily within this. So we can tune the search results to give it a better experience for our end users. Also, I didn't show it, but geospatial searches, that's something very neat that you can do here. You can pass through GPS information. So from my mobile phone, I can hit a search service I create that says something like, find me the closest Mexican restaurant within 5 miles of here, the best Mexican restaurant, or the closest 4-star hotel to me. So those kind of geospatial searches are possible very easily as well. And then auto-scaling. Right now we manually have to scale out to say that we need more capacity for query loads and things like that. In the near future, auto-scaling will be coming. And there's also, with the release of the most recent preview version, is the support for 20 additional languages. So we now have multilingual support beyond just English. And finally, just wrapping it up with some references. If you're interested in learning more, if you want to know pricing details, tutorials, look at the REST API documentation, your one-stop shop for all of that is at azure.microsoft.com. From there, you can find out everything you need to know about the search service. The AdventureWorks demo I showed is available on Codeplex if you're interested in looking at a real-world application and how it queries into the service. I highly recommend you check that out. Right now, there is no SDK to call into. There's no Microsoft release SDK to call into their search service. That is in the works, and that will be available soon. But until then, there is a community SDK released by Red Dog that allows you to wrap around the REST API, so you don't have to call the REST endpoints directly. You can use this SDK that will call into the REST endpoints. And then if you want to know more about this, there are plenty of Channel 9 videos and blogs that are available that go into a little bit more detail about Azure Search. In fact, Channel 9 itself is a good use case for this. They originally were using Bing Search for the searching of the Channel 9 data, but it wasn't provided because of some of the proprietary algorithms that Bing uses to rank sites and rank results. It wasn't providing the search experience that they were looking for, so they essentially just rewrote everything in a couple of weeks and built everything, switched everything over to use Azure Search in its preview form, and provided a very compelling search experience there for their end users. So there are plenty of production apps out there that are already using Azure Search. So it is a very functional service that Microsoft has given us. If you do have any questions, please feel free to reach out to me at rance@rdacorp.com. And there's also some other contact information here at marketing@rdacorp.com, along with telephone number and some contact information there. So with that, thank you very much for your time, and look forward to the next Tech Talk with you. Thank you. Bye-bye.